Hello, welcome to today's class. In this class, we will take one more problem on ideal gas. An automobile tire has a volume of 0.015 meter cube. So, volume is given 0.015 meter cube and contains air at a gauge pressure of 140 kilopascal. So, gauge pressure is given 140 kilopascal. So, kilopascal to pascal is 10 power 3 Newton per meter square. When the temperature is 30 degrees Celsius, so temperature is 30 plus 273, which is 303 Kelvin. So after the car is driven for a while, the tire heats up and the pressure increases. So these are all initial pressures, initial volumes and initial temperatures. So after the car is driven for a while, the tire heats up and pressure increases to 210 kilopascal. Now again, this is also gauge pressure. He has not mentioned, but since first pressure is given in gauge pressure, it is also given as gauge pressure. Assuming the volume of the tire remains constant, so V2 is same. V1 is equal to V2, 0.015 meter cube. So volume is constant, very important. Okay. Determine the absolute pressure initially and finally. So we are interested in finding out the absolute pressures. Absolute pressures. Of course, we want P1 and P2. So this is P2 gauge, P1 gauge. Now we are interested in absolute pressure, and remember, when we were defining PV is equal to MRT, we have said that the pressure is absolute and temperature is absolute temperature, that is temperature must be in Kelvin. And we are interested in T2, the final temperature of air in the tire, and he has given you atmospheric pressure. So we must consider the atmospheric pressure as 100 kilopascal. 100 kilopascal. Remember, if there is a pressure, absolute zero pressure, and there is atmospheric pressure. So according to this problem, it is 100 kilopascal, and measured pressure, that is gauge pressure, is here. Gauge pressure or measured value is from above this 100 kilopascal. So atmospheric pressure is considered as reference, and then the value is measured. This we call it as gauge pressure. So we can write, if you want absolute pressure, it has to be measured from the absolute zero. So this is your absolute pressure. Absolute pressure. So this is our gauge pressure. Therefore, absolute pressure, we can write the equation, absolute pressure is given by gauge pressure plus atmospheric pressure. Okay. So gauge pressure, for example, if you want P1, gauge pressure is 140 kilopascal. So 140 kilopascal, and atmospheric pressure is 100 kilopascal. So I am adding it in kilopascal only, then later I will convert it into pascal. So 140 plus 100 is 240 kilopascal. So initial pressure, we can say, is 240 into 10 power 3 Newton per meter square. So this is our initial pressure. Similarly, if we go for final pressure, P2 is equal to P gauge, that is P gauge 2 plus P atmospheric. So that is 210 plus 100. So that is 310 kilopascal, or we can say 310 into 10 power 3 Newton per meter square. Now let us come back to the question. We were asked to find out absolute pressure and initially and finally, that is done. The final temperature of the air. And remember, any automobile tire, if you drive it for a while, the temperature and pressure obviously increases. So here he has said that volume should be considered as constant. So considering that the volume of the tire remain constant, we must find out what will be the temperature of the air in the tire. And this is important if you want to avoid any accidents. So, it has to be taken into consideration. Now, let us find out the temperature. What do we know about the ideal gas equation? PV is equal to mRT. And remember, we have combined Boyle's law and Charles law, and we had deduced this equation is equal to PV by T is equal to mR. So, this is constant, but here volume is constant. So, therefore, we can say P by T. I will send V also to the right side, mR by V. So, P by T will be constant for a process where volume is also equal to constant. So, we can say P by T is equal to constant. What does that mean? P1 by T1 is equal to P2 by T2. Okay. So, now P1 is known to us, it has to be absolute pressure. So, 240 into 10 power 3 divided by T1 in Kelvin 303 must be equal to P2 310 into 10 power 3, and T2 is the only unknown which we are interested in. So, let us find out T2 is equal to in Kelvin. So, let us solve this equation as it is. We can say 240 into 10 power 3 divided by 303, and we use this alpha equals 310 into 10 power 3 divided by, we use alpha x, then we go for shift, solve for x is equal to 0 and press equal. So, 391.375 Kelvin, 391.375 Kelvin. Okay. So, we will take real gas in the next class. Thank you.